Hello, everyone. Just let me, yeah, can you hear me? Just one person needs to reply just to say you can hear me. Yeah, that's great. Thank you very much. Hope you've all had a good week. We're going to carry on from where we left off last week. Basically, I'm just going to go through some fundamentals, really. This is probably stuff that you've encountered before. So we treat it as a bit of a refresher, preparing us for our assessment, our assignment, which will be out next week on the 16th, which I think is the Monday. Someone emailed me asking me, how do they do well on their assessment? And, quite a reasonable question. I replied that the best thing to do was to come to these chat sessions, because I will be using these chat sessions to go through the assessment, pointing out how you approach it and how you do your best on it. Yeah, hi Ahmed, and hello everyone. Okay, so I'm just going to get my slides ready. Let me just get them prepared. So you should be able to see some slides now. Just let me know if you can't see them. So I'm going to talk a bit about this concept of entities and relationships between them and how we think about them, primary keys and foreign keys, etc. A word that I'm going to use a lot, both probably today and going forward, is the term context. And by context, I'm sure you all know what context means, but specifically the context in which we as database developers operate when we're designing and developing databases. So this is the particulars of any one particular business or organization, or within the terms of assessment, within the scenario in an assignment. And I'll speak a lot about that specifically next week, but I will be talking about context today and how important it is. Now, you've all encountered this concept of an entity before. Now, entity is just another word in English for thing. It's a very vague word. But we use it in databases to refer to those things that we wish to store information about. And that can be something fairly obvious, a thing that we can point to, like a student in a student record system. Something slightly more abstract, like a course or a module in a student record system. So we can't really necessarily point at a module, because a module is something that involves, lectures, tutorials, some assessment, etc. So it's a kind of less material thing than an actual student, but it's still something that we're familiar with. It's a kind of organizational structure, or whatever we want to call it. And then sometimes we have entities that are slightly even more less material than that. For example, the concept of a student taking a module. And that might be a thing that we want to keep information about. We'll come back to that example in a little while, because, how do we picture that? Well, we all know what it is. A student takes assessments, studies the lectures, etc. But again, it's not something we can point to. We can point to a student sitting down and studying and saying that's a student taking a module. But we know that we mean something a bit more deep than that. So this concept of things is a kind of broad concept. It can involve all sorts of different things. And the point is, it's contextual, that word again. it depends upon what we want to store information about. And that depends on our scenario, our organization, etc. So the concept of entities. When we come to implement our database, actually you're using a database management system like MySQL, Oracle, or whatever, these entities become our tables in our database. So sometimes, lazily I use the terms interchangeably, but one operates at a more conceptual level, the level of entities, and with diagram, etc. One, tables is a much more implemented thing. Now, I'm not going to go through all the slides. I'm just pointing out some things. Excuse me. To make a few points. Yeah. So here we have some entities. We have some people. Our entity is called person. One person. That car is called car, one car. And we have what we call instances of those. So we have some particular people, Vic, Beryl, Mary, as we can see on our slides. Our car, we have some instances of car, with different registration numbers. We also have this other entity here, which is, again, one of those things that's slightly less concrete in a way, this concept of drives, which represents a relationship between particular people and particular cars, as we can see. So particular people are matched up with particular cars on this entity that we've called drives. So here we note a couple of things. We note that we've got entities which are information about things, person, car, etc. We've got instances of those particular people, particular cars, and we've got another entity that's modeling some kind of relationship between those two things. And this is quite common to have this kind of set up in a relationship set. So we link entities through this idea of relationships. So here we've got a relationship between person drives and car and drives, and that represents a person driving a particular car. We notice this one here we've got person and car, we've got that relationship. This relationship might represent the person driving a car, but it's not represented here as an entity. Whether we represent that kind of relationship as a separate entity is something we need to think about as we model data. Again, this is something that I'll talk about quite a lot. Now, we have this concept of cardinality. This is how much of one entity relates to how much of another entity, basically. And I'm sure, again, this is something you will have come across. Interesting thing about this slide is that we've got the same two entities, person and car, and we've got 4 different relationships between them. So we can have person and car a 1-to-1 relationship, person and car a 1, what we call a many relationship. This is 1 to asterisk. Asterisk can mean any number that we don't know. So 1 to many. Here we have many to 1. So person, many to 1, car. And here we have at the bottom, we have a many to many relationship. And you might ask, well, what's right? What's the correct relationship? Again, I come back to the word that I've used before, which is context. When we go into a situation where we need to model some data, we can identify entities. The relation, and the entities that we identify will depend on the context, of course, because we model what we need to keep data about. But also the relationship between entities depends on context. So there's different contexts here. So person and car 1-to-1 is each person drives 1 car, each car is driven by 1 person. Each car is driven by 1 person. The third one is each person drives one car, but a car is driven by many people. And the bottom, the many to many, is each person drives many cars, each car is driven by many people. And again, what's correct depends upon what the situation is. Imagine this is a company that gives its workers cars as part of their, part of their employment. Well, they might have any of these setups. One person might have a dedicated car, and that car might only be for them, in which case the first one would be right. Or, the company might have lots of cars, they might be driven by lots of people, any person might drive any of those cars, then the bottom one would be right. There's no correct answer unless we know the situation, which is part of the sort of skill set that we're developing here, is to think about this idea of the context. What is it that we're trying to model? What is it that the business requires of us? Well, that depends, and that's part of our job. To understand that. If we were in a real situation, if we were database developers, we might do all the sorts of use all the skills that we've learned as systems analysts, like interviewing, observing, looking at documents, etc., as a way of understanding what it is that a business requires. Because on this module we're focused particularly on databases, those requirements will be laid out a bit clearer, as though someone has spoken to the organization and elicited these requirements. Afternoon, character. Okay, so again, this is something you'll be familiar with. I think something else you'll be familiar with is that when we move from this conceptual level of entities and the relationship between entities, this bottom one, this many to many, is something that we can't implement on a database. We have to do something about this, and the clue is earlier. We would have to have something like a drives entity in the middle. But I'll come back to that in a minute with a different example. We have this concept of keys, don't we? We talk a lot about this with the primary keys and foreign keys, etc. And I'll be speaking about that a bit more as we go. But let's just look at this example here. And this is taking us a bit to look at many-to-many relationships as well. A primary key is an attribute or set of attributes that uniquely identifies an instance of an entity. To use the sort of terminology of tables rather than entities, a record in a table, a row in a table, must have an attribute or series of attributes that uniquely identifies that record, that by itself, either in combination, one attribute or combination of attributes by itself, must be different from every other record in that table. We don't have duplicates. Now, sometimes it's obvious what primary keys are. For example, here we have students and modules. The hash just means number, by the way. Student number uniquely identifies a student, and I've looked in lots of organizations as lecturer and teacher, all of them have a student number for a student. That's because, using names is problematic. People have similar or the same names. So we give people numbers, and you'll have lots of numbers, if you're parts of different organizations and so on. So that's fairly straightforward. We have a student, they have a student number. We have different modules, and we want to tell one module from another, but then, we might have two modules called database development, and they might be at different levels, for example, and they're both called the same thing. But so we give things a module code, because again, names are never trustworthy. We tend to not use names to uniquely identify things. So we also have this concept here of this entity student module. Now we have student module because we can't this student and module is a many-to-many. If we just had student and module, like here, it's a many-to-many. We can't implement that. Why can't we implement that? Because if we've got a foreign key, we always have a foreign key where there's a many end to a relationship. So you see that here, this is one to many. So this is many, i.e. one to asterisk, one to asterisk. So this is many to many. So this is a many end, this is a many end. That would mean that we would have the module code on the student as a foreign key, but we would also have the student number as a foreign key or module. And that could lead us to have contradictory data. So what we do is we do what we call decomposing. We put an intersection entity in, and we always do it like this, and we say, well, a student taking a particular module is represented by a new entity called student module with a foreign key of student number and a foreign key of module. And that's there. Now, how does this look in terms of data? Well, here we have some data. We have particular students, each with their unique student number, and we have particular modules, each with their unique module code. Student number is the primary key of student, module code is the primary key of module. What we do is, because we've got the foreign keys here, we've got student number here, we've got module code here, that represents a student taking a module. So the data looks like this. We've preserved the many-to-many relationship. Many students can take a module. So for example, we've got the module code ending in 60, which is databases. We've got 2 students taking that, and therefore we can have many students taking that. The same student can take many modules. For example, we've got the student ending in 04, which is Vic Page, is taking databases and is taking software quality. So we've preserved that many-to-many relationship by creating this intersection entity with its 2 foreign keys. We have what's called referential integrity. This is important here. That means we can't put a student on module that doesn't exist on student, because this is a foreign key. It must mean that student must exist on the students table, and that module must exist on the modules table. Now, the sharp-eyed amongst you might have noticed that just as we've got an underline here to indicate that this student number is a primary key, and an underline here to indicate that this module code is a primary key, we put a star on each of these to indicate that these are foreign keys. We've also now underlined them. We've underlined them to say that student and module code together constitute the primary key of student module. Why do we need to do that? I'm asking you. Does anyone know why they both need to be part? Why the primary key of student module is made up of both the student number and the module code? Can anyone answer me that? No one's typing. Let me rephrase the question. Could the primary key of student module, the student module entity, could that be student number on its own? Why not? Someone says no, and someone says yes. We've got all sorts of different answers here. Someone says yes because it's also unique. This is the salient point. Student ID student number is unique up here. One student number, one student. Because any student we will keep their record once, won't we? We don't need to have the same student record on the student table more than once. Student number down here is not unique. Ignore the module code. So imagine the module code, just ignore the module code. Remember, a primary key on its own must uniquely guarantee that instance, that record is unique. Well, in that case, if we just look at student number here, the first record is the same as the second record. They're both K00004. Because the student is taking two different modules, that student number appears twice. So on its own, student number can't be the primary key. This is the same with module code. If we look at module, we got the same module appearing more than what we could potentially. Yeah, we've got the same module appearing more than once. First record and the third record, because many students can take the same module. Module code is not unique on this on its own. So remember, a primary key on its own has to uniquely identify a record. Student number or module code on their own do not uniquely identify a record on the student module table. They do here, module code does here, student number does here, but not on the student module table. Therefore, we need the combination of them. What this is saying, by making them both part of the primary key, is that a student, what uniquely guarantees a record here is the combination of student number and module code. And we look at our data, very small data set, and that's the case. We can't have either of them on their own. We have to have a composite primary key. Now, we look at this data, it works. And there might be other attributes on this student module table. There might be like the grade that they got for taking that module, for example. What would happen if one of the students failed the module, but this was a college or university that allowed them to take it again? We either have to overwrite their previous grade, in which case we've lost data, we've lost the history of the grades they've got, or this primary key wouldn't work. Because, say for example, Vic Page took databases again, there would be the same student number with the same module code. We'd have to include something else in that case. We'd have to include something like the semester or the year or the term or the date or something else. You know, imagine there are other attributes here. The point I'm trying to make here, again, using the word that I've used a lot, is context. We don't know what the situation is at that college. Maybe this college doesn't allow people to resit their modules, in which case this would work fine. But if it doesn't, if it's a case that it does, so if it does allow them to, we need to keep a record of that, in which case student number and module code together wouldn't be enough. We might have to have 3 attributes in our primary key. Now remember, students sometimes get confused here when I talk about this. There is one primary key here on student. There is one primary key on module. There is one primary key on student module. It is one thing made up of 2 parts, but it's still one thing. If I say what's the primary key of student module, you don't say, well, it's got 2, it's got student number and module code. No, it's got one primary key. It's just made up of 2 parts, the student number and the module code. This is important. When we regard them as a primary key, we consider them together. Now, part of your challenge, and obviously I'll be talking about this in a lot more detail next week, part of your challenge when you come to your assignment is modeling things like this. It's thinking about, well, doing the fairly straightforward job of identifying the main entities, student and module, thinking about the relationships, identifying when there's many-to-many relationships, decomposing, creating intersection entities, and then thinking about how the primary keys work. This brings us into the question of normalization as well, which we'll come back to, because normalization can help us here identify that. And we use a kind of dual approach of using entity relationship modeling and normalization to kind of think about things about how we model. But it is a process. It's not necessarily something you can you'll see straight away in terms of you look at the scenario and think, right, this is the model. No, it's a process where you have to kind of investigate the scenario, look at the sample data, and think about how you will model it. And this will be your challenge, which I will help you with, and I'll outline the ways in which I can help you with that as we go on. Now, the other parts of this lecture, I'm nearly finished now, but I'll just briefly touch on them. Things like fan traps and chasm traps are just useful for spotting. So understanding them is just useful for spotting where you've got problems with your data. I'm not going to go through them both, but briefly look at chasm trap. Where am I? Here we are. If we've got a relationship like this, where we've got a branch of an organization and one, staff work at one branch, a branch has many staff. And this is a property company, and particular members of staff manage particular properties are managed by staff. This looks fine. This looks like quite a good way of modeling this data. The problem is that we can't tell which branches which branches manage which properties. So if we look at the data, we go and look at this. This is one-to-many. This many relationship is from 1 to infinity, but this one is from 0 to infinity. So in which case we might have properties that aren't yet allocated to a member of staff, and that would be completely valid. And that's the case we've got here. Hill House has not been allocated to a member of staff yet. Because they've not allocated to a member of staff yet, we don't know who that member of staff is, and therefore we don't know which branch manages that house. In order to know which branch is managing a particular property, we need to know who the staff is. So there's a problem with this kind of setup. Now, it's not the case that you'll necessarily encounter this. I mean, it's just to be thinking along those lines about how the different entities relate to each other. The other thing that's in these slides, which again, I'll finish on this, is this concept of superclasses and subclasses. I don't want you to worry about this at all at this stage. This is part of what's called the extended entity relationship model. This whole concept of superclasses and subclasses. You will not need to be using these in your assignment. What you'll be needing to use is just the simple entities and relationships between entities. And I will go back to this and make a final point before I go. We identified early on, where are we? That there's these 4 different types of cardinality. Now we know that if we've got a many-to-many, we're going to need to decompose it into 2 one-to-many relationships. These one-to-many relationships will go which way they go depending on the context of the business. What about one-to-one relationships? Well, they are not that common. If something has a one-to-one relationship, why do we not just store it in one table? Now, there might be a semantic reason for that, in the fact that a person is different from a car. But a person is different from their address. But if a person has one address, we might store that information on an entity called person or student or member of staff or whatever. So although there might be a semantic a difference in meaning between a person and their address. There is. It's quite common to see address stored with a person. What about a car? If they're just allocated one car and that car is just only ever allocated to one person? Well, we could potentially model that in a person table. The person, their details, date of birth, name, etc., their address, the car that they've been allocated. So one-to-one relationships are not that common. Many-to-many relationships we have to decompose. So really, nearly all the relationships that you will be using in your assignment will be some form of one-to-many relationship. Okay? Now, I'll come back to this next week because we're out of time, and I will look closely at your assignment, which is due out on the 16th. Okay? So go out. I hope that's useful to you, and I will see you all next week, and I hope you all have a very good week, okay? Okay then, bye for now, everyone. Now, the assignment isn't due on the 16th of March. The assignment is issued on the 16th of March, okay? So don't worry, don't panic. Look at your assessment area on the VLE, okay? Bye, everyone.